I'm going to do a couple stretching and compression problems. First one I'm going to do is very straightforward. The second one I have has a couple extra elements, so let's get straight to it. The first one I have is 2 times the square root of x, and this is y is equal to, or f of x is equal to 2 times the square root of x. And the first thing we want to do is figure out if this is going to be a vertical compression or stretching or a horizontal compression or stretching. So if we take our base function to be the square root of x, we can see that we have a constant multiplying that base. So we're going to have a vertical stretching or compression. And since this is not a fraction, it's greater than 1. If this was a fraction, say like 1/2 or 1/4 or 1/5, then it would be a compression. It would be making the y values smaller. But you see, we're getting our normal. Think of this as like modifying our base function. So I normally think of, whenever I look at these algebra equations, I try to break it down into what's the basic function that's governing everything here. And the basic function is the square root of x. But on top of that, we're multiplying all the y values by 2. So that's going to cause a stretching effect, because we're going to get our normal, when we put in an x value, we're going to get our normal square root of x value, but then it's going to be multiplied by 2. So it's going to be twice as large as normal, and that's going to create a vertical stretching. And if you think about that from if you look at that from a vertical perspective on a graph, that's stretching. If it had been f of 2x is equal to, and then we put this into our function, the square root of 2x, then this is going to be horizontal. And this would be a horizontal compression. But anyways, we know it's vertical, so let's graph this. And you might want to make a table, or you might just want to, the way I usually do it, I have a lot of experience doing graphs, so for me it's very easy just to think of the base function and then just change it a little bit. I think of the graph of square root of x, and then I just multiply it by 2. So what I usually do, so let me write the function over here. F of x is equal to 2 times the square root of x. So it's going to start at 0. And then normally the square root of x is, if I put in 1, I'm going to get the square root of 1, which would be here. But it's being multiplied by 2, so I'm going to get 1, 2 instead of 1, 1. And let's pick another point that'll give us a simple one. Let's pick x is equal to 4. When we have x is equal to 4, for the normal square root of x function, I would have gotten 4. Or if I put in 4, I would have gotten 2. So I would have had the point 4, 2. But it's being multiplied by 2, so the y value is going to be twice as great as this one. So I'm going to get, in fact, 4, 4. There it is. And here is what the graph would look like. Now let's put our square root of x function just for comparison. So we would have had 1, 1, and we would have had 4, 2. So here you can clearly see the vertical stretching of this. This function is always going to be twice as great. It's going to have twice the y as this one, always. So that's what's causing the vertical stretching. So now let's move on to the next one. And this one has a couple of things. So we have 2 times x plus 1 squared minus 3. So here we have not only some kind of compression or stretching, but we also have an x plus 1 and a minus 3. So if we recall from our previous section, this and this are horizontal and vertical shifts. Now let's figure out what those are. We have an x plus 1, and when we have a plus to an x, that means it's going to be a shift to the left. So we have a left shift by 1 unit. And this minus 3 is going to cause a downward shift of 3 units. Now let's try to think of what our base function is. Our base function is x squared, and we have a 2 times it outside. We do not have 2x squared. This would be horizontal. So again, we have a vertical shifting, or not a vertical shifting, a vertical stretching, because this is a number that is not a fraction. It is not making the y value smaller. It's making the y values twice as large again. So we have a shift to the left by 1, a downward shift by 3, and we have a vertical stretching of 2. So twice as much y. So let's graph this. Again, let's rewrite everything down here so it's clearly visible. So we had a left 1 unit, down 3 units, and vertical stretching of 2. And again, you may just want to make a table for this, or you can use a sort of template method, which is the kind of one I use. What I do is I think of the graph x squared. And then I'm very familiar with what x squared looks like. I know the exact shape. I know how much it increases when I go over 1, when I go over 2. If I go 1, 1, if I go to 1, I would have been at 1. If I go to 2, I'll be at 4. If I go to 3, I'll be at 9. So I know very well that graph. So what I usually like to do is just think of that graph and then change it. So I go down 1, or to the left 1, down 3. So this is where the center of this graph is going to be. And normally, if I didn't have a vertical stretching of 2, I would just say, okay, if I put in 1, I get 1y. So I would go up 1 unit. But in fact, since there's a vertical stretching of 2, instead of going 1 over 1 up 1, I'm going to go over 1 up 2. And the same thing's going to happen for a negative value because it's symmetrical. And normally when we put in 2, we get 4. So I would have gone over 2 and up 4. But I'm not going to go over 2 up 4. I'm going to go over 2 and then up 8 because it's being multiplied by 2. So I'm going to go 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. Right there. And same thing for the negatives. I'm going to go from the vertex, I'm going to go over 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. Here is our graph. And this is the way I like doing it. If you're not comfortable with it, you can make a table. That's perfectly fine. I thought I would just show this way of thinking where you think of it as its base function, and then you just almost like make a recipe of what to do in order to change it to look like that function, rather than just plugging in points and getting points. Just think of it as x squared and then change it from there. I guess real quickly, let's put on our x squared just so we can see what it looks like stretched out. So let's do this as well. The minus will go over the left 1 and down 3. So we go over 1, up 1. So that's, if we put in 1, we get 1. If we put in 2, 1, 2, we would have gotten 4. 1, 2, 3, 4. So that would have been here. 2, 4. That's a little bit low. And if we had put in 3, 1, 2, 3, we would have gotten 9. So this was up 8, so this would be right up here. So you can see that this original function increases more slowly than our function f of x is equal, well, this is equal to x squared, but our other function is f of x is equal to 2 x squared. And actually, in fact, what we have plus. Let me rewrite it. I did not include the transformations. So f of x is equal to x plus 1 squared minus 3, and then the other one is f of x is equal to 2 times x plus 1 squared minus 3. So we can see when this one is 2, this one is already 3, and it's only 1 more than it. So this one increases much, much faster. When this one is 3, this one's going to be 18. So this one is always going to be twice this graph at any given x value. This graph is always going to be twice as much as this graph, and that's what the 2 means. So I hope this was helpful in working through these problems. It's really just a matter of just doing the problems and being familiar with what each of the base functions look like. The x squareds, the square root of x, just the very, very simple functions. If you understand those graphs really well, you're going to have a really easy time with these once you understand the basics of what is happening when we add something, we subtract something, we multiply something. It'll be very simple for you just to think of your just x squared, and then just be able to say, okay, I go left one, I go down 3, and it increases twice, and then the y is twice as great, and then you can just make a graph really quickly. So definitely work on those, and you'll be alright.